In this video, we are going to work on common data manipulation tasks and tools. We're going to start with the data we used in the prior videos. So these packages were ones that we already had in our libraries. I'm going to introduce two new ones, so dplyr or dplyr and SQLDF. So that's a SQLite language in a data frame setup. So this allows us to do some SQL language in R, and this dplyr gives us another way to do data manipulation. In some instances, one package is easier than the other, and I'll show some of the steps with each of those packages. So we would run these in to the library, and these steps were things we did previously. And now we have the data frames over here in our environment that we had already created. So now we want to add some new things, and there were a couple of things that we didn't clean up in the last videos. So the first one is we have two dates in the invoice table. So if we look here, we have lowercase date and uppercase date. In R, so dplyr works with the R framework, and so it recognizes those columns as two different columns. SQL, when we read in SQLDF using that function, it's not case sensitive, so then it will think those two are the same columns. So we're going to remove this date column, the lowercase date column, from the invoice table, and I need to introduce a couple of functions that come from the dplyr package, and that will introduce how we're going to use this later as well. So the first part is we're going to create a new object invoice table. The arrow tells us we're going to do these other things to it and to do what these steps that are over here and read them into this object. And what the steps are is we're going to start with the invoice table. So we're using the same table to overwrite to a new object that is named the same as the old object. Then this pipe function is new, and this is from dplyr, and this says whatever is on the left of the pipe function, take that object, whatever you've created over here, and continue on. This says continue on doing something else to it. So here it's going to be selecting columns, but what this does is if you run this pipe function, it tells R to wait because something else is coming after it. If you were to just run this line by itself, it would think that it's waiting for something else, and R would just be waiting, and so it'll look like nothing is happening, but that's because the pipe function tells it to wait. So we take that table, look for to do something else after that, and what we're going to do is this function that says select, and by select it means choose columns. So if we were to just put date in there, so here I have a negative, a minus sign. So here, if we don't have that, that says only keep that column. If we put a negative number in, or a negative sign in front of it, that says remove that column. So select is to select which columns you want to keep in it. We look at the invoice table, notice over here we have both of those date columns. We run this back in the invoice table, the lowercase date has been removed. Another thing that we didn't change was that we have product ID in one of the tables. So here we have product ID as prod ID. Here we have it as product ID. So we're going to change this product ID to prod ID. And we're going to use this rename function. So rename function says take a data set or a data frame and then rename the columns that come after that. So here we're going to create a new column, prod ID, which is the same as product ID column. So in other words, it's renaming this product ID column as prod ID. So we can run this one too. Notice it's product ID right now. Rename the column, now it's prod ID. All right, so now we have things all set up that will allow us to do some merging. If you remember from a prior course where you did one-to-one merges or relational databases, one-to-many, one-to-one, You need to have some primary keys that will allow you to merge the tables. So they are already in there, and dplyr, what it will do if you don't tell it what the primary keys are, it will just, or what we're merging on, it will just use the common columns. So here we're going to take invoice table, pipe function says continue on, so from invoice table, left join, so this is one to many, so it will take every row of the invoice table and merge it onto every one of the invoice customer IDs as many times as there is a match. So this is the one side, this is the many side. Then same thing with left join, we're going to continue on. So after we've already done this join, we're going to continue on and left join product table. So we're doing two different merges here, both of them the same way. Most often I use left join. There are other ones you can look up, inner join, full join, things like that. But the process is still the same. So temp 1 is now created based on these joinings. We can go ahead and look at temp 1. And notice what it has done is take what we had already, these first 4 columns, and now it's put in customer ID from the one data frame and then added sales price from another data frame. So now we've merged these all together. The common ones get sort of, they're the keys so they don't get added in again. So then we can just work with this data frame. So it works nicely, looks good. Let's do it with SQL in the SQLDF package. So the SQLDF package just has this one function, SQLDF, which says create a SQL statement. If you remember from a SQL statement you had to do in an earlier class, there's a create table. Well, that's not in this one because we're using the R language here. So you would have a create table or a pen table or something like that first. That is used by here, this create an object temp2. That's like saying create table. And we're going to do the SQL statement to feed into that object temp2. So in the SQL statement, there are typical functions. So we always have a select and a from, and then the other parts are optional. Here we're going to select A, so we can have this shortcut to a table. So I'm going to name invoice table shortcut A. So A dot star means everything, all columns from the A table. B dot customer ID, so B I'm labeling invoice customer ID as B. So take the customer ID column from that table. So we're going to take from this table, left join the invoice customer ID table. Notice it's the same as we did right here. And we have to tell it how we're going to join it. So if it's a left join, we use on. If it is another type of join, we might use where. And maybe at some point we'll do that, but since I use left join most commonly, we'll do left join and on. And what we have to do is tell it this column in the first table A equals this column in the second table B. We run this. Notice in temp2 we've got 5 variables, so we're partway there. It pulled in the customer ID, the other table, all of the columns are there. Now we're going to take temp2, do the same thing, take temp2. Notice I didn't create an alias for temp2, no shortcut. So I'm using temp2 all columns, and then I did create a shortcut for product table. So B, in that table use column sales price. So from this temp2 we're going to left join the product table, and how we're going to combine them is from the temp2 table use product ID or prod ID, and then from the B table, which is the product table, also those have to be the same, that product ID column. On this, now we've got the combined data. So we have 2 different ways to do this. I would say normally the dplyr is the easiest and fastest way to merge, but it isn't as flexible. So if we need some strange merging to be done, the SQL df is useful. Plus, there are lots of instances where you may use SQL in the future. So that's merging them together. Now we're going to manipulate the data that we already have. So we have this data. This is what we're going to work with. So I'm going to introduce you to some functions and ways to manipulate this data to create new columns or to change these columns in ways that are really common to be done. So the first one, let's create a new column. So we have number ordered and sales price. If we go back here, this is the number in that transaction of that product that were ordered. This is the sales price for that product. So we're going to multiply those together to create a new column that is the total revenue on that transaction. So I'm calling it sales tot. We're taking that data frame temp1. Mutate is to change columns. So it's manipulating the columns is the mutate function. So we can put in here a new column that we want to create equals whatever we want to put here. If we had other columns we wanted to create, we could put a comma and add, create another column. We could do it as many columns as we wanted here. So we're going to mutate to create a new column. We look over here in temp1. We now have 7 columns, and one of those is this sales total column. We can do the same thing with SQL. So again, select. We're going to select all of the columns that are currently there, and we're going to create a new one, which is number ordered times sales price, and how you name that column is say as, and then the name of the new column. This is from temp2. So this will do the exact same thing. Notice it looks the same. So different ways to do the same thing. Some of the things are, these are equivalent basically. There are some other things that are easier to do in one of those methods or not. So next one we're going to sort, and here I want to sort by customer, product, and date. So take temp1, read it into temp1 again. Arrange is the dplyr function for sorting, and we just need to put the columns in here that we want to sort by. If we wanted to do descending, a sort that goes the other direction, we could put a minus sign in front of one of these. Or if it is a date, we could do descending date. But we're sorting ascending, so we can just put all of those columns in here. Temp1, we arrange it or sort it, open it up. Notice we have the customer ID. These are all the same customer. It's by product, so they're in order of their products. Notice this customer bought L3 twice. All the other ones it bought once. And then we can do the same thing with SQL. So select all the columns from temp2. Order by is what we use to sort the in SQL, and it's the same thing here. Order by in most of the functions has to come later. So if we have a whereby clause or a merge, that has to come before order by. So there is a order that the SQL statements have to go in. So we run this, temp2, same thing, we can open it up, and there you go. A couple of things that are useful, so if you were interested and there are some problems with that you don't quite understand this dplyr or the SQL df, here are some websites that you can go in and look at more information about them, trying to figure out the details of them. But here we've covered the main parts, but there's more to them. All right, so we sorted them. One of the things that happens a lot is we might want to look back at prior rows or at later rows. So in here, when this is sorted, let's say we have these 2 products that were the same. Well, maybe in this row where this is June 18th, 2020, and the total sale for this product was 1,000. Maybe we want to look back at the last time this product was ordered and what was the total sales amount that time. So we would want to look back a row here and we could collect this 12,000. So they ordered a lot more this last time, they ordered a little bit this time. Well, that seems easy when we look at it. Just take this, go up a row. So in the functions, lag is what we refer to as go up a row. So if it's sorted in order this way, we can just go up a row. But if we're here, this is the first time L3 was ordered, we go up a row, L3 doesn't exist, so it should be missing because we don't have a prior version for that. And there are a couple of things we have to do to tell it that we don't want to go back. So if we did a lag without worrying about that, then the last time that, if we were to put a new column in there, the last time that L3 was ordered, we would get this $143,000, but that's incorrect because there was no prior version of L3. So in dplyr, the way we do that is group, and so that means for every group, we will run this lag function separately. So for each customer, each product, we'll do the lagging. And if we go back to a new customer product pair, then it won't go back beyond that. So group by in dplyr, what it does is say anything we run after that is done by those groups that are here. So mutate, we can go ahead and create a new column. I'm going to call it last order, and lag is the function that we'll use here. So I'm going to lag sales total by 1. So go to the previous sales total, go up a row. And then group by is a weird part about dplyr. It will save the grouping in that data frame. And sometimes that can create some weird things when you didn't expect it to be grouped. So I ungroup whenever I group by prior to that. So we run this, and again, we'll always check what happens to it. So look over here at temp1. Notice here, we're at the last order of L3. Go up a row, that's 12,000. That adds that to this new last order column. So what that would allow us to do is calculate something like if we wanted to see how much it changed, we could subtract the sales total minus the last order or something like that. But notice these other ones are missing because they don't have any lagged values for that particular customer and product. We can go down and see some places where there were multiple orders of the same product for the same customer, and it fills in all of those. To do the same thing with SQL, it's a little more clunky, so that's why I tend to use dplyr when I'm doing these lags, but you can still do it. So select all columns. We're going to create a new column that is as last order. Here is all the stuff we're going to do to it, and then we're doing that from temp2. So here's this language that we need to think about. So lag sales total, so that's just going back one row. And then how we tell it to do it is over. The over is for rolling window functions in SQL. And then here's how we make it work by groups. So partition by means group by in essence. So do it for each of these individual groups, which are the same groups as we had before, and order by tells it what the object we're sorting by when we're lagging the sales total. So it's a little bit to sort of get your hands under, but once you have the language, it's not that hard. So temp2, same thing. Notice it sets it up the same way. All right, let's do a couple of other possibilities. I'm going to do a cumulative function, and those are just way easier in this than they are in SQL. You can do it, but it's easier here. So let's do it in dplyr. So temp 1, read into temp 1, sort by customer ID and date. So notice I'm not sorting by product. And then group by customer ID. So I'm doing this for each individual customer, not by product. So it's ignoring the product and just doing by customer and date. So if we wanted to look at this, so we can run this here. Notice I didn't include the pipe function at the end. Run it, look in temp 1. So it's sorted by customer and by date, and those aren't necessarily by product. So if we group by customer, it's going to do these manipulations by each individual customer. So here's one we could do is the row number. So within each customer, it's sorted by date. Just count the rows that are in that group. That would tell us how many orders there were. So that we're just counting how many transactions we have for that customer. Another one is we could sum up all of the sales. So here I'm doing CUM sum. That's the cumulative sum of the sales total. And I'm going to call that cumulative sales. So if I run those are going to create new columns. And notice what happened. So within this customer, it's just counting the number of rows, which gave us the number of transactions. And here it's adding up all of the sales as they go along. So a few functions. There are some other ones that we'll encounter as we go along that allow us to do lots of different types of functions. These I think are the most common, and then we'll introduce more as we sort of progress. But if you want to figure out what other options there are, or you encounter something that you need to do some manipulation that you're not aware of, then these websites are a good starting place. Or again, if you aren't sure how to do something, Google is your best friend. All right, have fun with this one. Again, there will be one in KNIME for you to follow along as well.